Okay, this is one of the common problem being asked in Amazon, and most of the TCS and QT is asking this question. This is called a grid problem. Basically, the name of this problem is called grid problem. What is that is it is also present on LeetCode and the problem number is 62. What is that? I have one grid having some dimensional. Let's consider m into n. M is number of rows and n is the column. I want to navigate from top left corner, this is the corner, to this corner, bottom rightmost corner. While navigating from topmost left corner to the right corner, how many possible ways are there that I need to calculate? So for 3 into 3 matrix, it will be total 6 possible unique ways. There is one constraint here. Either I should move on the right direction or I can move on down direction. We cannot move on the left direction and we cannot move on top directions. Only we can move is a right direction and down directions. So we need to find all possible routes from this to this directions. Okay, from top left to top bottom right corner. This is my destination, this is my source. Now how we can calculate this one? So the given matrix is of, let's say, 3 rows and 7 columns. It is tough to identify, so better to understand is using 3 into 3 matrix, and once we solve this problem we can solve for any dimensions. And the same problem was asked in TCS NQT, and the problem is called maneuvering a curve. Basically this is the same problem. We are moving the matrix, okay, having the dimension n into m. Only we can move is on the right direction or down directions. So to understand this one, to simplify, let's consider I have the matrix of 1 into 5 matrix. Basically I have 1 rows and number of columns are 5 columns. So what is the unique path? There is only one unique path. The solution is 1 because I don't have any alternate options. So only one unique path is there. So 1 row 5 columns, solution is 1. Now I'm considering 5 rows and 1 column. These all are 5 rows. This is 1 row, second, third, fourth, and 5. Only we have 1 column. So how many possible ways we can navigate from source to this destination is only 1. So the conclusion is either of m or n. Here m is 1, here n is 1. This is m into n, this is again m into n. Either m is 1 or n is 1, the solution is 1. This is one conclusion. Either m or n is equals to 1, solution is 1. Now with this conclusion we try to find 3 into 3. Now this is the representation of 3 into 3 matrix where I have 3 rows and 3 columns. So what all the possible ways? The solution we know is 6. So this is my first path, unique path. This is my second path. This is my third path. These 3 paths, okay, in one color. One more is this path, and this path. Total I have 6 solution. It was easy to find for 3 into 3, but you cannot even calculate if I increase the dimension from 3 into 3 into 4 into 4. It is too tough. So we need to build the logic based on base condition. What is that base condition? 1 into 5, solution is 1. 5 into 1, solution is 1. That means either m or n is 1, solution is 1. Now this is called base condition. Do you remember why we use the base condition? Especially when the problem is of the type recursion, we use base condition, because on the base condition we are going to terminate the recursion call, otherwise it is going to be infinite call, right? That's the reason we use base condition. Without base condition there is no recursion problems. Now with this one we'll see, instead of this source to destination, if I pay attention on the destination for reaching this cell 3 comma 3, so what all the ways I can reach? Either I can reach from here or from here. We cannot reach diagonally, right? So that means this location m into n, I can reach from here or I can reach here. So solution of this one is depends on solution of this coordination and solution of this coordination. If I add these two, I will be getting the solutions. Here instead of going from source, I am trying to solve the problem from destinations. My destination is, even though m into n matrix, I will solve from destination, not from source. So solution of m and n is depends on this coordination and this. So what is the coordination of this cell? This is m minus n, m minus 1. For example, here m is 3, so here it will be 2 comma 3, right, and remains same. So this coordination is m minus 1 because I am moving one row lesser, right? Now what is the coordination of this cell? This cell is, row is same but column is decreasing, that's why n minus 1. So for a given cell m n, I need to find the solution of m n minus 1 plus m minus 1 and n, because we have only two ways to reach these solutions in the same way. Okay, this is called the recursion. This cell depends on this one and this one. So what is the coordination of this one? M minus 1 comma n. Here it is m n minus 1. So in this way recursively we are going to call till I reach 1 1. Either m is 1 or n is 1. So we knows the solution, by the way. Either n is 1 or m is 1, solution is 1, because we already seen here it is 1 into 5 matrix, solution is 1. Here even though 5 rows and 1 column, solution is 1. This is called the base condition. So we are trying to find for how many matrix? What is the dimension? 3 into 3. Now this m into n, this is my ultimate solution, which is based on solution of this coordinations. Okay, this is called m minus 1 into n and solution of m n minus 1. Let's start with 3 and 3. 3 and 3 is depends on m minus 1 means this is m, this is n. So instead of 3 it will be m minus 1 means 2, right? N remains same. So what is n? 3, it was 3 plus m. M is 3 as it is, n minus 1 is this minus 1, it is 2. So solution of 3 comma 3 depends on the solution of 2 comma 3 and solution of 3 comma 2. Now do we know the solution of this one? No, still we don't know. Do you know the solution of this one? No. So I will take one by one. Okay, this I am going to calculate here, this I am going to calculate here. So 2 comma 3 depends on, now m and n is 2 comma 3, right? This is what we are going to trying to find the solutions. M minus 1, this minus 1, it is 1. Okay, 2 minus 1 is 1, n as it is, m is 2 as it is, n minus 1 is 3 minus 1 2. Yes, 1 comma 3 I will not take. Do you know the solution of this one, by the way? Yes, it is, since either of 1 m or n is 1, either row or the column is 1, solution we knows it is 1. So I will not consider this one, so I will take the second one. By the way, we solve for this one, this 3 comma 2, 3 comma 2 I am taking here. Okay, this solution is, we still need to find m is 3, n is 2. first m minus 1, it is become 2 instead of 3, n is as it is, and 3 as it is, 2 minus 1 is 1. Now 1 comma 3 I will take. Okay, 1 comma 3. I am not trying to find any solution for this one because I know 1 comma 3 the solution is 3, 1 comma 10 solution is 10, 1 comma 100, yes, solution is still 1 because we have only one path, even it is 1 into 100, solution is 1. That's the reason if m is 1, solution is 1. Now we got this one. Okay, 2 comma 2, 2 comma 2 depends on this, 2 becomes 1 since it is m minus 1, 1 comma 2 and 2 comma 1. So can you see here, here m is 1, here n is 1, the solution is 1. So this is how recursively we are going to call. So let's find the ultimate solutions. Here we trying to find the smaller solutions. These smaller solutions will try to fill up in the recursive call. Ultimately, after getting the solution of this one and this one, add up this one, so we'll get ultimate 3 and 3 solutions. I'm writing the same thing. Only difference is that 3 comma 1 solution is 1, 1 comma 3 solution is 1. Okay, and 1 comma 2 solution is 1, 2 comma 1 solution is 1, 1 comma 2 is like this. Yes, it is 1 comma 2 solution is 1, 2 comma 1, how we can represent 2 rows 1 column, solution is 1. That's the reason I am trying to fill up the solutions. So this is ultimately base condition it is reaching. Okay, so 1 comma 2 I am writing 1, 1, 1 plus 1 is this solution, plus this solution is 2. So the solution of 2 comma 2 is 2. That means for 2 comma 2 matrix, the solution unique path is 2 from source to destinations. This 2 and 2, we got the solution. This solution I am filling up here. Okay, now 3 comma 1, yes, we know the solution. Even though it is 3 rows 1 column, still the solution is 1, so I am writing 1. We know the solution of 2 comma 2, which is 2. So this 1 plus this 2, it becomes 3. So we know the solution of 3 comma 2 is 3. This I will fill up here. Okay, this is what we got a solution for this one. Now 1 comma 3, yes, it is, since it is 1, so solution is 1. 2 comma 2, where we find 2 comma 2, yes, here it was 2, so 2 plus 1, so it becomes 3. 2 comma 3 is 3. This 2 comma 3 I will fill up here. This is what the solution is. 3 comma 2, where, yes, it is here, it was 3, so this 3 and this 3 becomes 6. So for 3 into 3 matrix, how many ways are there? 6 ways. This is called the recursion call. And what is the base condition? Either m or n is 1, solution is 1. Based on this recursion base condition, we are going to terminate the recursive call. Let's go on the code. Okay, this is my method. M is the rows, n is the columns. Okay, if any of the row or the column is 1, result is 1. That's the reason very first thing is to check the base condition. If m equals to 1 or n equals to 1, return 1. Otherwise, okay, let's go on recursion call. This depends on this one or this one. So I will say m minus 1 and m n minus 1. This is what 2 times recursively we are calling, and once we get the result, we are adding those 2 results. Okay, this is what the formula is. Solution of this one is depends on solution of m minus 1 and m n minus 1. So recursively call till we reach either of this one. Okay, either both are 1 or any one is 1, return 1. So if I run this program with rows 3 and 3 and column is 3, so I will be getting the solution as 6. So this is how we can simplify the grid solving problems.